Okay, let's continue. So we have here's an example of the mechatronic systems, because in this washing machine we have, for example, system requirements as the understanding of the load size, because for example you put more clothes into this washing machine, or you put only small wedge of the clothes. Next is the receptacle of the holding clothes, and plumbing, agitation of the drums, and the ease of use, reliabilities, low cost. Here is all the requirements, and then we have to design the washing machines. So we can also use actuator as AC motor, DC motor, due to which one has more advantages for which, how to say, for example, AC motors is actually good for changing of the for example, AC motors, when you would like to change the speeds of the motors, you have to change the frequency of the currents. But in the DC motors, you need additional also control system. For example, you need PDW, power width modulations, to control the speed of DC motors. And next actuator is water inlet drain. So we need also pump in the waters into this washing machines, or we pump it out. Next is the sensor. We also use the sensor to detecting the level of the waters. Is this really enough or not? And next is the load and the speed balance. For example, we also have to measure the speed of the motors, how fast it's rotating. Last one, the controller is depend on the choice. I think in this case, of course, we use microcontroller. Next is, oh no, my bad. Here, of course, not washing machine. Here is the, of course, Azimo or humanoid. Here, human robot. Okay, so we have, we have also system requirement as AI intelligence, able to walk without fall. We are avoiding obstacle. We have the cam, interact with the human. We have reliability and safety. And actuator, of course, we have AC motor or DC motors, depends. But in this case, I think it's DC motors here, because we have a pack of batteries. And the sensor is the camera sensors. We have force sensor, we have gyroscopic sensor also, but this gyroscopic also detecting the orientation of those of the azimuth. And of course, control is the choice independent. Normally, if we have the actual class face to face, I will conduct the group task. But if you are interested, you can also try to think about the mechatronic system in your house. Actually, there's anything. So boiling of the waters, or heating waters in your showers, or air conditioning, or the car, motorcycles, for example, the plane also. So we can also derive the system requirements. What is the requirement for the boiler or the actuator? What is the heating system? And also the sensor. Do they have a sensor or do they not have it? And the controller systems. Normally, as I told you before, the picture in the first very first slide, we have the controller system, and then here is more details. We have the controller. So this is microcontroller. This is a reference value, so we set this value to be a target. And then we have actuators. This is the plant control system. we have the actuator as a motor, for example, we have a process, for example, and then the output here go out, we also have disturbances. For example, when you have air conditioning in your closed room, actually the temperature outside, so you know already in the afternoon the temperature outside is super high, and it's also affecting to your closed loop system, to your rooms. This is what we call disturbance. Okay, and then we have a sensor also have noise, but we are not really taking care of it. For example, as I told you before, this kind of noise also coming from how selectivities of your sensor it is. So is your sensor pick the other signal other than detecting the temperatures or not? And then after getting this feedback, it send the signal back to the reference and then measure if the temperature is lower or higher than the reference, and then it send the error to the controller. This is the whole loop. And the example is here. For example, if the temperatures as an output, okay, and then I say 25 degrees Celsius, I set this as a target, and then this is the times, maybe in minutes or seconds, and you can see this is unrealistic. Actually, maybe your room, the graph should be other way around, because our temperature starting with really high, but maybe here I would say it's the heaters. Maybe you are living in the North Pole and the temperature is 0 and then you turn on the heater, and then the heater rise the temperatures until it reach the target here. But you know already, it's not like we are shutting off and the heater is stopped right away. Is we overshoot a little bit here and then when it's overshoot, the controller will receive the error, and then they say, oh, it's too high temperatures, and sorry, so it's too high temperatures, let's shut off the heaters, and then the temperature going down a little bit until the and also it's also have some errors here. If your controller is not good, you have steady state error. It mean permanent errors there, but I will not go into details because this related to also the type of controller you use in the system. Okay, so next, the block diagrams. So we have we normally formalize the control system as a pictures, and the component can be combined to produce the overall mathematics description of the systems, and the interact between elements is well defined. So for example, here we have a open loops. What is open loops? We don't have sensor. Okay, imagine your bread cooking here. Normally we set the time because the temperature is high, but it will not detecting any temperature there. You set the temperature, it just heats until the timer is clocked, and then it stops. And here is an example for the open loops. We have a heaters, we have a room, we have outside temperatures, we have the energies, and we have a valve. So if it open loops, when you set the temperature to, for example, number 1 as a 16 degrees Celsius, so the energies or the heaters will keep feeding the heat influenced by the valves. So for example, if you set this as 1, the valve open a little bit. The valve open a little bit. If you set it 2, the valve open a little bit more. If you set it 3, the valve open widely. And then this is the heating system, and then it supply the heat. And then the heat go into how much amount of the heated air going into your rooms is depending on the valve here. Okay, and do you think this valve can detecting the temperature in the room? No. So this is really related to how much do opening the valve here without knowing the room temperatures. For example, if you putting the number 1 in the summer, you might get the temperature of 30 degrees Celsius. And if you put number 1 in the winter, you might get 15 degrees Celsius. Okay, so the temperature outside really is the main influence to the room temperatures. So that's why this is called open loops. We didn't have any sensor to detect the temperature in the rooms and then send back, okay, the heater is not heat enough, so please sending more the heat and then open more valves. For example, open loops, remember open loops didn't have this kind of features. So disadvantages, no exact adjustment of the temperature possible. So the winter and the summer, when you set it to 1, the temperature will be different. And the influence of the temperature outside is not taking into considerations. That is why. This is called open loops. And next is the closed loop. Here, the closed loop is known as the feedback control system. Maybe you already seen. This is a closed loop here because we have a sensor. But here I will show you the example of the real closed loops. And it's repeat again. I show this because this kind of equations or mathematics equation systems of this controller. Actually, everything here can be calculated, okay? And then the errors, as I told you before, the errors here is this to DNF, different of DNF, okay? And this F also coming from K multiply Y by the outputs, alright? So actually you can derive the system by this one. Okay, so next is the closed loop systems. The real closed loop system. So we have a motors. Now we have a motors here. We have a motor connected to the valves so that we can control the flow of the energy or the flow of heat air into the rooms. And then we can set exactly what temperature do we need it, because if it in the winters, if it in the summer and then we set it to the 16, we know we need a lot of heat to heat these rooms, okay? And then it will feeding back, it will measure the temperature in the rooms and then it's sending the signal to the controller. And if the differentiation between the set temperature and the actual temperature is quite large, means the valve will open very wide. It will open like fully opens so that the energy, the heat energies will going into the rooms. Okay. And if it is in the summer, in the winter, and the temperature is quite low in the outside and the inside, means, for example, the differentiation of the errors between the sensor and the set temperature is not that high, means the motor will open the valve only a little bit so that it not overheating the rooms. So the advantages, of course, of this one, we have exact possibility to adjust the temperature to be the target, and the influence of the temperature outside can be also considerations. But what is the disadvantages of this one? So we need sophisticated understanding of the mechatronic system and control systems to doing this kind of things, because we need someone to programming the controller, we need someone to connect the sensor and the motor together, and then we need also some tests. Okay, so this much more expensive than the open loops. You can see already. Normally, you know already we have a warming system for the waters in the showers. So for example, when you use the cheap one that cannot control the temperatures exactly, but it's just heating the waters. That one we call open loops. You know, we have a shower. I might write this. We have a showers, okay, and then before this we have a water heating system. If the price is about 500 to 2000 or 3000, I quite guarantee that it's open loops. So you can just adjusting this high or low, but you cannot control the temperatures. This is what we call open loops. But if you buy a bit higher price, and then you can really set the temperatures there, then this is the closed loop. So it has the sensor. It has sensor inside to detecting the temperature difference, and it's also have microcontroller to get the signal and then send the signal to heating system. Okay, we have to open more valves, or we have to heat more the waters, for example. Yeah. So here is the real application in the world. And normally the air conditioning is always in the closed loop, because you know if it open loops, then it's like a freezer. So in the winter. Okay, so I think that is pretty much for today. So if you're interested in, you can go into these links. It's also have a good example of the controller, and also the good for exam and exercise. Okay, and there will be a last this is the last lectures, but there will be also a next how to say, the last review of the class for the final exam. So thank you very much for today, and have a good day and stay safe.